Hello again, everyone. Welcome back to our course in college algebra. Dr. Tom McNamara here, using the document camera for this one. This next series of videos will concern transformations of functions. So the key ideas that I want you to take away from this topic are the fact that changes to a function's formula affect the graph. Okay, changes to a function's formula affect the graph, and these changes occur in very predictable ways. Now, before we can make effective use of this, we need to know how graphs look to begin with. Okay, if you don't know how to start, then you won't know what to do with the changes. So, what we're going to do in this video is go over several graphs to remember. So several graphs to remember. So let's go and discuss the first of these several graphs to remember, and actually it's one we already know. It's the graph of f of x equals absolute value x. Okay, so I'll draw myself a grid right here. Okay. So we know this is a familiar V shape right there. Now, I want you to remember more than just the basic shape, okay? I want you to remember some anchor points on these graphs so you can draw good graphs very quickly simply by moving the anchor points. Okay, so for example, 0, 0 is an anchor point on the original function's graph. So if I were to, let's say, graph the function f of x can we distinguish that's a slightly different color there, f of x equals absolute value x minus 1 plus 2. Okay, and this is something we've already discussed, but I've replaced x with x minus 1, so that is going to be a shift right 1 unit, and over here that's going to be a shift up. So I can move my anchor points, go right 1 unit, go 2 units up. And now, right, I'm moving 0, 0, 1 unit right, 2 units up. I'm moving 1, 1, 1 unit right, and 1, 2 units up. Okay, so I very quickly get an accurate graph without a lot of work by moving my anchor points. Okay, so another function that we are already familiar with, I hope, is this one right here. F of x equals x squared. Okay, once again, quick little grid. Okay, this function also goes through 0, 0, goes through 1, 1, and it goes through 2, 4. And I guess if you want, it also goes through 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 comma 9. Okay, so 0, 0, 1, 1, 2, 4, 3, 9. And of course we connect the points on our graph with a nice smooth curve. This function is symmetric about the y-axis. So if you know the points on the left side, you get points on the right side for free. Okay, so once again, remember the basic shape. It's a U shape called a parabola. But also remember your anchor points, in particular 0, 0, 1, 1, and 2, 4. And then don't forget that you get these other points for free using symmetry. Okay, so for this library of functions to be effective, you need to remember not only the basic shape, but the anchor points. Okay, there's a couple more that I want to show you for right now, and we will expand this library of functions later on in the course. And I guess really you might say it's not a library of functions, it's a library of graphs. Okay, so two more. Okay, next one. This is a new one for us. F of x equals square root x. Okay. Draw myself a set of axes here. X-axis, y-axis. Y equals f of x. Notice I didn't spend a lot of real estate on the left side. That's because this function's domain is the set 0 to infinity. Remember, the domain is the set of values we are allowed to use as inputs to the function. Well, the instructions for the function tell me to look at my number and then take the square root of that number. And as we know, if we take the square root of a negative number, we get a complex number answer. So we're going to want to restrict ourselves to positive, or at least non-negative inputs only. And it happens that the range is also 0 to infinity. So let's look at our graph here. Let's remember some anchor points. Square root of 0 is perfectly fine. You can take the square root of 0 and you get 0. If you take the square root of 1, you get 1. If you take the square root of 1, 2, 3, 4, if you take the square root of 4, you get 2. Okay, so some anchor points here. 0, 0, 1, 1, 4, 2. 5, 6, 7, 8, 9. If you take the square root of 9, you get 3. We connect these points with a nice smooth curve. Okay, so here's a graph that is increasing, kind of starts increasing a lot at first, but then it sort of flattens out. Okay, so the graph of f of x equals square root of x. Okay, and one more picture that I'd like you to remember for our library of graphs. And that is the graph of f of x equals x power 3. So once again, set of axes. Let's go right here like such. Okay, so graph goes through 0, 0. That's an anchor point for this. 1, comma 1. Now how do I know 1, comma 1 is on the graph? Well, remember the x value is the input, the y value represents the output. You take 1 and raise it to the third power, you get 1 back. What if I put in 2? Well, I take 2, raise it to the third power. 2 power 3 is 2 times 2 times 2. 2 times 2 is 4. Multiply by 2 again, you get 8. So if you use 2 as the input, you get 8 out. 1, 2, 3, 4, 5, 6, 7, 8. 2, comma 8 is on my graph. Okay, so once again, we connect these with a nice smooth curve. Okay, you might notice a little similarity between this and the graph of y equals x squared. And it is kind of similar, though this is much steeper. Notice with the graph of x squared, our jumps were jump of 1 and then a jump of 3, because it goes through 2, comma 4. There's a much bigger jump there. I also want to note that if you use a negative input for this function, you get a negative output. Okay, negative input here gives a negative output. If I take -1 and cube it, it is -1 times -1 times -1. 3 negatives give me -1 out. 2 common -8. 1, 2, 3, 4, 5, 6, 7, 8. 2 common -8 is on the graph. Okay, and here is where we really see the difference between the graph of x cubed and the graph of x squared. Okay, so 2 common -8 way down there. I might need to zoom out a little bit so we get the whole picture on camera here. Okay, so the graph of x cubed, you got this shape here. Up as you go to the right, but over here, we got this behavior. So not only do I need you to remember the picture, remember the anchor points. Okay, so 2 new graphs. The graph of the square root function and the graph of x cubed. Commit these graphs to memory. We are going to be making use of these pictures to get graphs of other functions. Okay, so we are adding to our library of functions.